Okay, I have a bit of a lame joke here, but you're not really paying me a compliment here. The complement, known as A prime of a set, is really all the elements that are in the sample space that are not in set A. And so you might notice that over here, here's the universal set, this rectangle, and let's say this red circle represents set A. Well, then everything out here in the green would be A prime. So notice that if you intersect A and A prime, you get nothing because there's no place that they intersect. But if you take the union, if you put A and A prime together, you get the entire sample space. Well, if that's the case, then the number of elements in the union of A and A prime must be the same as the number of elements in the sample space. So if that, then that means that the probability of A union A prime must be the same as the probability of the sample space, and the probability of sample space is 1. So the probability of A union A prime is always 1. And since you can since there's no intersection, you can write this as the probability of A plus the probability of A prime, because that's the rule we just covered for the probability of a union if there's no intersection, and so that must equal 1. So for a complement, let's say that you have two sets, E and E prime. So I'm going to use E instead of A, since E is usually used for events. So the probability of event E plus the probability of not E is equal to 1. Okay, so a couple of corollaries that come off of that. If you solve this for the probability of E or solve it for the probability of not E, you'll find the answer is 1 minus the other probability. So for instance, the probability of E is 1 minus the probability of not E, and the probability of not E is 1 minus the probability of E. And this is pretty handy sometimes, because sometimes it's easier to calculate the probability of a complement, or the probability that event doesn't occur, and then we can just subtract the result from 1 to get the probability that we're looking for. So like a simple example here, if 4 coins are tossed, what is the probability of getting at least one head? Well, the complement of at least one head would be getting no heads. So basically what we could do is find the probability of getting no heads, and there's only one way out of 16 to get no heads, so the probability of getting at least one head would be 1 minus 1/16. There should be a minus right there. 1 minus 1/16, which is 15/16. Now you can actually avoid using the complement, but sometimes it makes more sense. This one you could probably figure this probability without using the complement, but I'm going to use it. It's a simple case of using the complement. It says 2 dice are tossed. What is the probability that the dice will be different numbers? Well, basically there's a lot of pairs of dice, the ways the dice can land to be different numbers. It's easier to find the probability that they are not different numbers. In other words, that they are the same number. So let's let A be the event that the dice are different, and then A prime would be the event that the dice are not different. In other words, they're the same. And we can easily get this because there's only 6 ways out of 36 that can happen. So the probability of A prime is 6/36 or 1/6. So now all I have to do to find the probability of A is subtract that from 1. So just take 1 minus 1/6, and so the probability that the dice are different would be 5 out of 6, 5/6. Example 2 says, suppose 2 fair dice are rolled. Find the probability that the sum of the numbers rolled is greater than 3. Well, let's let A be the event of a sum greater than 3. And lots of ways that can happen. So let's find the event of a sum not greater than 3. Well, notice there's only 3 ways that you can get a sum not greater than 3. So the probability of that event would be 3 out of 36, or 1/12. So now all I have to do is subtract that from 1. So say 1 minus 1/12, and now the probability that the sum is greater than 3 would be 11/12. So let's take a look at one a little more complicated. Let's say 8 cards are drawn from a standard deck. What is the probability of getting at least one face card? Okay, now remember, when the total number of 8 card hands would be 52 choose 8. So let's say E is the event of getting at least one face card. So that would be getting 1 or 2 or 3 or 4 or 5, 6, 7 or 8 face cards. Well, E prime is the event of not getting a face card. So that would mean the only way that can happen is to get no face cards. So I can easily find the probability of getting no face cards. That would be the number of ways to get no face cards, which would be 12 face cards choose none, times 40 non-face cards choose 8, over the total number of 8 card hands, which is 52 choose 8. And that's 0.1022. But that's not what I wanted. I didn't want the probability of not E. I want the probability of E. So the probability of E is 1 minus the probability of not E. So I do 1 minus 0.1022. And I get 0.8978. And so that's the probability of E. The birthday problem is a special problem that's discussed in probability, and it goes like this. How many people would you randomly select in order to expect there to be a 97% chance of 2 or more people having the same birthday, excluding twins, of course? Okay, so basically what we're trying to do is, let's say we have a certain number of people in a room and we want to know the probability that 2 or more have the same birthday. Well, basically the probability of not having the same birthday is easier to calculate, because the probability that 2 or more do not have the same birthday can be calculated this way. And then if you want the probability that 2 or more do have the same birthday, you just subtract that from 1. Now, I'm not going to go through how I got this, but you can view this video here or do some other searches for the birthday problem on YouTube and you can see. But just trust me, it's much easier to find the probability that no 2 people have a matching birthday than it is to find the probability that 2 or more have a matching birthday. Now, if you were to do the class for 30 students, you would get the probability would be about 0.7, or a 70% chance that 2 or more would have the same birthday. I actually do have the development here, and you can skip this if you want, but if not, you can pause the video and just read through here and see, and notice that I find the probability of not E right here, and then I convert that. I use a little trick to convert it to a more compact formula where I get this. So that's the probability of not E, and then for the probability of E I just subtract that from 1. And here are a few calculations that I looked up here. But let's not dwell on that. Let's go ahead and go to a quality control problem in manufacturing. Let's say a shipment of 45 cell phones contains 9 that are defective. So the quality control department randomly selects 10 phones from the shipment and tests them. The shipment is rejected if at least 1 in the sample is found defective. Okay, what is the probability that the shipment is rejected? So basically, I want the probability of at least 1 defective. Okay, so I want the probability of at least 1 defective part. But that's hard to do because the probability of at least 1 defective part would be, I'd have to find the probability of 1 or 2 or 3 or 4 all the way up to 9. So it's easier to find the probability of no defective parts, because I can easily get the number of ways to get no defective parts. So out of the 9 defective, choose none, and then out of the 36 good ones, choose all 10. and then if I divide that by the total number of samples possible, 45 choose 10, that gives me a probability of 0.08. And then to find the probability that at least one is defective, I do 1 minus that, so there's a 92% chance that it is rejected. And that pretty much completes the lecture on the complement. You'll find that probability and odds are not 100% the same. The probability of an event is really this ratio: the number of ways the event can occur over the total number of possible outcomes, where the odds of event occurring is this ratio: the number of ways the event can occur to the number of ways the event cannot occur. Some people think they're the same, but they're not exactly the same. Let's take a look at converting probability to odds. So this is how you convert a probability to odds. So let's say you have the probability of E is 7 out of 11. Well, that means there's 7 ways for the event to occur for every 11 outcomes. So ask this question: how many ways are there for the event not to occur in 11 outcomes? You should have gotten 4. So that means that the odds in favor of E occurring are 7 to 4. So, and these are the 3 common forms to write it: 7 over 4, 7:4, or just simply say 7 to 4. Okay, here's another example. Let's say the probability of an event is 8 out of 31. Well, that means there's 8 ways the event can occur, and if you take 8 from 31, it's 23 ways that it cannot occur. So the odds in favor of the event would be 8 to 23. So for every 8 ways it can occur, there's 23 ways it cannot occur. By the way, if you wanted to know the odds against it, you just flip the odds in favor of it around, and so the odds against the occurring would be 23 to 8. Now, if you want to convert odds to probability, you simply do this. If you want to convert the odds, let's say the odds are 7 to 5 and you want to convert them to probability. Well, 7 to 5 means there's 7 ways the event can occur to every 5 ways it cannot occur. So that means there's a total of 12 possibilities. 7 plus 5 is 12. So the probability would simply be 7 over 7 plus 5, or 7/12. Okay? Now remember, odds can be greater than 1. They're not like probabilities. You can have odds that are 10 to 1 or even 100 to 1. So there are some formulas that you can use. You can read these formulas here, but really you don't really need the formula if you understand what probability and odds are. See, here's a probability 7/9. So the odds in favor of this, well, there's 7 ways for it to occur, and that means there's 2 ways that it can occur. So the probability would simply be 7 to 2 would be in favor, and then if you flip it around, the odds against it would be 2 to 7. And if you know the odds are 8 to 5, then you know the probability is just 8 over 8 plus 5, which is 13. Here are some other examples that you can look at. So pause the video and look at these and see how I convert probability to odds and odds to probability. Read this last example. Out of 1,000 people, 500 people tried soda, 600 people tried soda B, and 200 tried both. And if we randomly select somebody, what's the probability the person has tried soda A or soda B, and find the odds in favor of this happening? Well, I drew a Venn diagram here, but all you have to do is just look at the Venn diagram, and from the Venn diagram you can see there's 300 plus 200 plus 400 that tried A or B, so that would be 900 out of 1,000, which is 9/10, and that, if you change that to odds, you get there's a 9 to 1 odds in favor. And then for the other 2 questions, you can look at the Venn diagram and answer those as well. So the probability that they tried only 1 soda would be 300 plus 400, so that's 700 out of 1,000, which is 7/10, which converts to 7 to 3 odds. And then the last one converts, it's 100 out of 1,000, and it converts to 1 to 9 odds. So That's pretty much it on this section. So you can read this little blurb down here, and that pretty much covers